This mouse has been suddenly struck by an overwhelming sense of impending doom. Here's the thing. Hunting is hard. The majority of predator attacks, they fail. A chase wastes insane amounts of energy, and if you don't catch your meal, you just burned calories for nothing. That's why the best hunters don't waste energy on running things down. They get close enough to catch them instantly, and silence is how they do it. Predators that rely on silence aren't just being sneaky. They've undergone selective pressures to develop structural, behavioral, and even neurological adaptations that make them more efficient killers. Their anatomy is fine-tuned to minimize sound production. Their nervous systems control movement with extreme precision, and their hunting techniques exploit the sensory limitations of their prey. Noise is just energy. Every movement creates vibrations that travel through air, water, or solid ground. These vibrations propagate as pressure waves, which are detected by specialized receptors in prey species. The trick to silent hunting is controlling how much of that energy escapes. Let's start on land. Big cats, lions, leopards, tigers. They all use the same silent stalking formula. First, soft foot pads. Big cat foot pads contain thick epidermal layers over a subcutaneous matrix of collagen and fat tissue, which act as shock absorbers. Instead of transmitting force outward, they dissipate kinetic energy internally, reducing sound production. Second is direct registering. Their back paws land in the exact same spot as their front paws. This isn't just about stepping in the same spot. It's a biomechanical adaptation that minimizes changes in body center of mass, reducing the amount of kinetic energy transferred to the ground. Fewer fluctuations mean less detectable vibrations. Third, weight distribution. Cats move with a digitigrade gait, walking on their toes rather than their heels. This elongates the stride and allows for more gradual force application. The tendons in their limbs store elastic potential energy, which smooths out their movements, preventing sudden, noise-generating impacts. Your cat at home still follows the same biomechanical principles. Even though they're not stalking prey in the wild, their locomotion is shaped by millions of years of evolutionary refinement. Bird flight should be loud. Wings push air. Air makes turbulence. Turbulence makes noise. But owls cheat the system. Regular birds have smooth wing edges, which create vortex shedding, a process where pockets of high and low pressure air interact, generating sound waves. But owls? Their primary feathers have serrated edges that break up airflow into smaller, less turbulent streams, preventing large pressure fluctuations. Their feathers aren't just modified at the edges. The entire surface of an owl's wing is covered in microscopic, hook-like structures that trap air, functioning as a biological sound dampening system. This reduces broadband noise across multiple frequencies, preventing prey from detecting them. And owls don't just reduce noise, they also alter their aerodynamic profile for silent gliding. Most birds rely on rapid wing beats, but owls have an exceptionally low wing loading, the ratio of body mass to wing area, meaning they can generate lift with minimal movement. Less movement means less sound. The result? They can approach their target with virtually no acoustic footprint. And this isn't just a mechanical advantage, it's a sensory hack. Rodents, a primary food source for many owls, have highly sensitive auditory cortices specialized for detecting predators. By eliminating high-frequency noise, owls bypass their prey's most effective early warning system. Water should make hunting harder. Sound propagates almost 5 times faster in water than in air, meaning any disturbance should give prey an instant warning. But sharks have evolved to be incredible stealth hunters. Most fish regulate buoyancy using a gas-filled swim bladder, but air is highly reflective to sound waves. This makes many fish acoustically conspicuous. Sharks don't have this problem. They control buoyancy using a massive, oil-filled liver. This not only makes them neutrally buoyant without needing air pockets, but it also removes a major source of noise. Their skin is covered in dermal denticles, microscopic, tooth-like scales. Unlike typical fish scales, Denticles reduce turbulence by redirecting water flow along the body, lowering drag and eliminating whirlpools that could produce sound. Their movement is highly economical. Most fish rely on oscillatory swimming, generating thrust through rapid tail beats. But sharks, particularly ambush hunters like great whites, use intermittent propulsion, storing elastic energy in their myotomal muscle structure to glide silently between bursts of movement. And their secret weapon? The lateral line system. This array of mechanoreceptors detects pressure gradients in the water, allowing sharks to see movement without relying on vision. This means they can minimize their own movement while still tracking prey, staying undetectable until the perfect moment. Then, at the last possible second, game over. Silent hunting works because prey animals are wired to detect any noise that doesn't belong. That's why predators don't just move quietly. They have to eliminate the exact frequencies that their prey is sensitive to. Speed is good, strength is great. But silence? Silence is the difference between a missed opportunity and a guaranteed kill. And now you know exactly why.